Hello, Algebra 2. Welcome to the notes video for Concept B, Graphs and Functions, which is the second concept in Unit 4C, Functions and Graphs. The learning targets for this lesson will be I will be able to analyze different functions and their graphs, including polynomial, radical, and rational graphs, and I'll also be able to give the domain and range of a graph. This is going to be part one of this lesson. We're going to be primarily focusing on that second learning target here in this first video, and then in the second video we'll focus more on the individual graphs. Let's talk definitions here though first. If we think back, we have really talked about these before, but in this case, for a function, instead of just being a set of ordered pairs, we are primarily going to be looking at the graph of a function. But the graph is going to be of the ordered pairs or the points of the form x comma y, or if you remember using function notation, x comma f of x. We also have talked about before that the domain of a function is the set of all the first coordinates of the ordered pairs or the x values. These are the set of inputs found on the x-axis. So we can think of that as how far left to right if we look at the picture. And then the range of a function is a set of all second coordinates of the ordered pairs or those y values, and these are the sets of outputs found on the y-axis, or you can think of that as how far bottom to top. We also are going to be using what we are going to call the vertical line test to tell if something is if a relation or a graph is a function or not. The vertical line test says that a graph is the graph of a function if and only if no vertical line, and that's the key there, that no vertical line crosses the graph more than once. So there's a couple pictures here, but if we remember, our definition of a function was that each x has to have exactly one y, and so for the vertical line test to work, it means that I can draw any vertical line and it's only going to touch that graph at one point. So in this case, this one passes and the VLT, we're going to use that abbreviation. It works. So this is a function, but the second one, yes, I can draw a vertical line right here and it's only touching once. But if I draw this vertical line right here, even though it's already drawn, we can see that it's hitting at two different points, which means that x value doesn't have its own individual y value, meaning this fails the vertical line test or VLT, meaning this is not a function. So let's practice that. In example 1 here, it says determine whether each graph represents a function or not, and then explain why or why not. So if I look at this first one here, I'm going to draw a couple vertical lines, but we can also just use those grid lines and we'll see, hey, each of those vertical lines are only hitting that graph at one point. So yes, this is a function. That's because it passes that VLT. If I look at the second one, I might start here on the left-hand side and notice, hey, my vertical line is only hitting at that one point, so that's okay. But if I draw any other vertical line here, it's going to hit twice. And so we will say, no, this is not a function by the VLT. Oops. And we can say, another way of saying, any of those points, since I drew my line at x equal to 2, x equal to 2 repeats, but really any of those vertical lines where it hits twice would do the same thing. And then for C, I'm going to draw a couple of vertical lines. And notice it is only going to hit at one location. So yes, this is a function by the VLT, by that vertical line test. Now, Now we're going to be talking about domain and range. We will often express the domain and range as a function of intervals. It is important that we are able to write these, though, as both inequalities and intervals. So previously, we have primarily talked about how to write domain and range in terms of inequalities, but we also need to make sure that we know interval notation. An interval, you can think of it as on the number line, it has to have a start to stop. And it's just like how we read, we'll always go from left to right, or in this case, most negative to most positive. So for example, if I have an inequality where this says x is greater than negative k, but also less than positive k, because we always want to read the inequality from saying x first, so x is greater than that negative k, but less than k, then that means that it is going to be starting from negative k to positive k. Now, since it is not included there, that means I don't have the equal lines underneath like I do down below. That means that it's actually not included at the actual value of k. Hence why we use parentheses or these open circles, okay? Now, if I am equal to, though, so like in this one, we have x is greater than or equal to negative k, but less than or equal to positive k, that means those k values are actually included in the interval. So I have brackets instead of those parentheses. And instead of an open circle, we're going to use a filled in circle, because I'm going from negative k all the way to positive k. That means my x value or my solution can be anything between those two values. Now, if I have an inequality where it's just one value, so for example, in this case, where x is just greater than k, that means that I am starting at positive k. Since it doesn't have the line underneath, it's just going to be a parenthesis. But since I'm greater than k, that means I'm going to go all the way to the right, which if I think about that, all the way to the right on the number line is that positive infinity. And so I'm going to write my interval as positive k to positive infinity. And since, again, we will always use brackets for values that I can actually exist at, since we can never actually exist at infinity, we will always just use a parenthesis on infinity. It doesn't matter if it's positive or negative. Speaking of, if I go to the next one, I have x that is greater than or equal to k. So again, I am greater than, so I'm going to put a bracket because I'm also equal to, but then I'm going off to infinity, so that's going to be a parenthesis. That gives me that closed dot, and then I'm greater than, so I'm more positive, meaning I'm going to go all the way to the right. And then lastly, if x is between negative infinity to positive infinity, that really means that's the entire number line or x-axis, so we can use that double bar r for all real numbers, and we'll write that as negative infinity to positive infinity, because I can go all the way to the left and all the way to the right. So let's practice going from the inequality to that interval notation. The very first one we want to do here is going to be negative 3 is less than x. So I'm going to start by drawing a number line. And then I always like to put 0 on my number line just because that will help us with the positive and negative. And so I know my value here is negative 3. So I'm going to go and put negative 3 on my number line, and that's less than 0, so it's to the left. And this is saying x is greater than, strictly greater than negative 3. So since it does not have the line underneath, that means I'm going to use an open circle. And since I am greater than, that means I'm going to be getting more positive, so I'm going to go to the right. So if I translate that to my interval notation, meaning bracket and parentheses, I know that the furthest left I'm going is at negative 3. And since it's an open circle, I'm going to use a parenthesis. And then since my arrow goes all the way to the right, I'm going to use a positive infinity. Now let's go to B. Once again, I'm going to draw my number line. I'm going to put 0. But in this case, I have two different values. So I'm going to put -1 to the left, 9 to the right, because that's where they would go on the number line. Notice how I'm not drawing each individual number on the number line. As long as we have a rough estimate of where it's going, i.e. on the correct side of 0, we're going to be fine. So really, we can think of this as two different inequalities. This one is saying, hey, x is greater than or equal to -1, and x is less than or equal to 9. So since they both have the lines underneath, that means at each point I have a closed circle. And since it is x is greater than -1, that means I need to get more positive or go to the right. But then it's x is less than or equal to 9, so that means I'm going to get more negative or to the left. Or really, this means that I'm just going to be shading in between those two circles. So if I were to write this in interval notation, since I have a closed circle, that's a bracket, -1, comma, to the furthest right, bracket 9. Let's go ahead and go to C and D. So I'm going to go ahead and draw my number line. I'm going to put 0. And notice here for both my values, they're both positive, so I need to put them both on the correct side of 0. Now, this one, if I were to branch this, this gives me two different inequalities. X is greater than or equal to 6. X is strictly less than 8. So based on those signs, at 6 on my number line, I'm going to put a closed circle since it can be equal to 6 as well. But I can't be equal to 8, so I have to put that open circle. And so if I were to shade there, x is greater than 6, so I'm going to go to the right. X is less than 8, so I'm going to go to the left. Once again, shading in between. And so if I were to write this in interval notation, this would be bracket 6 to 8 with a parenthesis. It's okay to have different parentheses or brackets depending on the sign. That's going to happen sometimes. And then finally, for our last one here, if I go ahead and draw my number line, I'm going to go ahead and put 0. Notice once again, they are both positive. So I'm going to go ahead and put 4. I'm going to put 6. Now, this one says x is less than 4 or x is greater than 6. So this one's a little bit tricky. But let's just start with each inequality and graph them individually. So I'm going to start with this guy. So if I have x is less than 4, so I'm going to put an open circle at 4. And if I am less than 4, then I'm going to go to the left here. I'm going to shade over there. But then if I do my second one, I'm going to do that in a different color, blue. I still have that open circle, but then that is saying x is greater than 6, meaning I'm getting more positive. So this is a case where I don't have the overlap between the two, but I can still write this in interval notation. I'm just going to write it, each of my shaded inequalities on my number line individually. So if I start all the way to the left, that left arrow is going all the way to -infinity. So I put that parenthesis on it, and then I keep on going to 4. So I'm going to put 4, and then I put a parenthesis, but then I have to jump to 6, where I have another parenthesis since it's an open circle, and I keep on going off to positive infinity. So I have these two different intervals, but I know that my answer can be in any of those intervals. So I'm going to connect them with this U sign, which is our union sign. That sign right there stands for union, and we use that to connect intervals. So anytime you see that word or, that's going to happen there. Okay, this is going to be the end of our interval notation and our vertical line test. Please continue to the second video.